13. If a slow step precedes a fast step in a two-step mechanism, do the substances in the fast step appear in the rate law? Explain. Okay, so suppose we have this carbon dioxide plus hydroxide ion, and then it yields to bicarbonate ion. Okay, so this one, the first step, number one, number two. Number one is a slow step reaction, and number two is a faster step. Okay, it's a fast step reaction. So we have, okay, since we have bicarbonate here, okay, the product in the first reaction, we have bicarbonate as the product. And then in the second reaction, because it's fast, so we use the product of the slower reaction, the bicarbonate, as our reactant. Okay. So this HCO3, the bicarbonate, okay, this one, HCO3 is our intermediate, okay, intermediate reaction. It is the one that is the product, and then we use it in our reactant, and it does not appear to our final product. So that is our intermediate reaction. Okay, so we have now when we write the overall reaction, okay, so HCO3 appears on the left side and on the right side here, so we can cancel that one. Okay, cancel, and then cancel. What else? Okay, no more. Now for our overall reaction, we can write CO2, bring down CO2, and then we have OH ion. Because they are two, we write 2OH plus 2OH minus, and then this yields to a product. The products are, since no HCO3 na, because it's an intermediate reaction. An intermediate reaction is a molecule that appears on the product, and then it involves in as a reactant for the second step, but uh, it was consumed. It was consumed because it does not appear in the final product. Okay, CO3 and H2O. So that is HCO3. HCO3 is our intermediate reaction. So we have our overall reaction. And then when we write the rate law, so we have rate law. Okay, the rate law is we base on the overall reaction. We have K constant times the concentration of the reactants. We have CO2, and then we have the OH. Okay, OH minus. Notice that in our rate law, okay, our question is, do the substances in the fast step appear? Okay, in the rate law, of course, no. So only only the reactants in the slow step appeared in our rate law. Okay, so we have our answer is no, because the overall rate law must contain only the reactants, no intermediate. And the overall rate is determined by the slow step. Okay. So remember, the Rate of reaction is determined by the slow step, not by the fast step reaction. Okay, so that's the reason now we cannot uh, see the substances in the fast reaction in the rate law because in a fast reaction we have an intermediate. Okay, a fast reaction is composed of the intermediate reaction, which is the product in the slow step, and then okay, the product in the slow step. But the product in the slow step is used as a reactant in a faster step, and it does not appear in our second product because it was consumed. That's the fate of intermediates. The substances are consumed. They appear in the product and they are used up. Okay, so our final or our overall reaction is CO2 plus 2OH minus and then CO2 CO3 2 minus plus H2O. And the rate is we base the rate to the rate law to the overall reaction. Okay, to the overall reaction. Okay, and also the overall rate is determined by a slow step, not the fast step. Okay, so that's all.